This video we can see arrays and strings in C programming. An array is a collection of elements of the same data type stored in contiguous memory locations. Elements are accessed using an index starting from 0. Arrays can be one-dimensional, two-dimensional, or multi-dimensional. The size of an array is fixed at the time of declaration and cannot be changed dynamically. Array manages and organizes data efficiently. It allows access to individual elements using index. An array is a data structure used to store a fixed size sequential collection of elements of the same data type. This means all elements in an array must be of the same type, like integers or characters or floating point numbers. Here is the syntax to declare an array. Data type followed by array name, and within the square bracket you have to mention the array size. For example, an array with the name numbers of type integer and size 5 is given, and another array of character type name of the array is name and size of the character array is 10. First element will be at the index 0 and the last element will be at the index total size minus 1. So in the numbers array, first element will be at the 0 index and the last element will be at the index 4. Array initialization in C involves assigning initial values to the elements of an array. This can be done at the time of declaration or later in the program. Initialization at declaration or initialization after declaration. Initialization at declaration has the following three types of initialization: direct initialization, implicit size initialization, and partial initialization. In direct initialization, array size is mentioned along with initializing the values. In implicit size initialization, array size is not mentioned, and with the number of values initialized, it will take the size of the array. And the last one, partial initialization. Here the size of the array is 5, but only two values are initialized. So automatically the remaining locations will be initialized with the value 0. The first two values are 1, 2, and the remaining three values are 0 in this array. One-dimensional array is a linear data structure used to store a collection of elements of the same data type in contiguous memory location. It is also known as a single-dimensional array or a 1D array. Here we have an example for one-dimensional array. A program with an array of name numbers, type of the array is integer, and the size of the array is 5. It is initialized at declaration. Values are 10, 20, 30, 40, and 50. So it will be assigned value at declaration itself. The contiguous memory location, the values 10, 20, 30, 40, and 50 will get stored. Followed by the declaration and initialization, a for loop which executes for 5 times the value of I from 0 to less than 5. The loop gets executed and displays the value of array one by one, and displays in the format element at index 0, value at index 0, and followed by element at index 1, the value at that index 1. This repeats for 5 times and displays all the 5 values one by one. Once the for loop is over, the program terminates by returning a value 0 to the operating system. A multidimensional array in C is an array that contains other arrays as its elements, allowing for the storage of data in a structured format beyond a single dimension. The most common type is a two-dimensional array, often visualized as a table with rows and columns. Values are stored contiguous in memory. and we use nested loops to access elements of the multidimensional array. Here is an example for multidimensional array where a two-dimensional array similar to a matrix is declared. The two-dimensional array size is 3 by 3, where it takes 3 rows, 3 columns. It is declared with initialization. After initialization, you can see a display statement where it displays the element at 1, index 1, 2. It means that at row 1, column 2, it displays the value 6. You can see in the initialization that in second row, third column value is 6, which takes the index position 1, comma 2. Followed by the display statement, we have two for loops, nested loops, where it reads all the values of the matrix one by one and displays the matrix values or the two-dimensional array values. Strings are arrays of characters terminated by a null character. You can use an array to store string, or you can use string literals. You can create an array of character type to store strings. Here the last character in the array will be null data. Each string is terminated by null data. Another way is using string literals, a pointer of type character to store the string, where the end of the string will be a null data. It is appended automatically. C provides several functions in the string.h library for string manipulation, like string length calculation, string copy to copy from one source to another destination. Let's see an example for string manipulation. Here we have an character array named string of size 100 and another array reversed of size 100. And we have declared two variables of type integer length and I, and getting the input string using fgets function. Then using strcspn function, we are checking whether there is a new line character and calculating the length of the characters in the string. And with that we are getting the length of the string, and using our for loop we are reading the string from the last position and storing it in the new array. Finally, we are appending the new array with a null value for the string termination, and then you can display the original string, reverse the string, and the actual length of the string. Another simple example for string manipulation, where we are getting a string input using fgets function and finding the length of the string using the function strlen string length, and subtracting it by 1 to find the actual length of the string, because null data will be there in the end of the string and the length of the string is displayed at the end. This is about sorting a list of array in a specific order. We have different algorithms to sort the list of array. So one of those is selection sort. In selection sort, the algorithm divides the array into two parts, sorted and unsorted. It repeatedly selects the smallest element from the unsorted part and swaps it with the first unsorted element. So the steps will be of like this. Find the smallest element in the unsorted portion, swap it with the first unsorted element. Repeat until the array is sorted. Here we have the program for selection sort. In main function, we have an array of size 6. So the values are initialized at declaration. We are taking the size of the array and storing in the variable n, and then calling the function selection sort, where array and the size of the array is passed as argument. In the function, we are reading the array values one by one, and we are going to Store the smallest element from the first index, and finally at the end of this execution we'll get a sorted array. You can see in the selection sort, first we have for loop. Within the for loop, first we are taking the value of I, that is index position, to which we are going to store the smallest element. So first the smallest element will get stored in the zeroth position, and on each iteration gradually it will move to next position. So on second iteration the smallest value will be in the first position, like that. And inner for loop will be reading array values one by one, and it compares with the other values. So the unsorted array will be compared, values will be compared one by one, and the smallest value will get stored in the first first position, the position which is mentioned by the minimum variable. Finally at the end of the loop, all the unsorted values will be in sorted way, so we get a sorted array at the end of this function. One more array operation is searching. Searching in C involves locating a specific element within a collection of data such as an array. Two common searching algorithms are implemented in C. One is linear search and the other one is binary search. Linear search is a simple algorithm where each element of the array is checked sequentially until the desired element is found, or the end of the array is reached. So it is suitable for unsorted arrays or when the array size is small. Binary search is significantly more efficient for large sorted arrays. If the array is unsorted, it must be sorted first for binary search to be effective. It repeatedly divides the search interval in half and performs the searching option. Using two-dimensional arrays, we can represent matrices. We can perform different operations on matrix. So common matrix operations are addition, subtraction, multiplication. So here we have an example program. So a part of the code is shared here. How an addition of two matrices is done. A matrix of type integer is declared first. So you can see the size of row and column as 3. Assuming matrix 1, matrix 2 and result are two-dimensional arrays of same dimensions. Here the addition of two matrices are given. Two for loops are used, where one for loop to traverse through rows and the another for loop to traverse through columns. On each row, the column values are added together and stored in the resulting array. So finally we get a single matrix with the sum of two matrix values. Keep practicing programs. Thank you.